The title of my presentation is What's New? Enthusiastically Realistic About 3D Printing. I use this title because that's how I label myself. That's the theme of the presentation, and it's also my goal. I want you to leave your seats enthusiastically realistic about this technology. And where I'm operating from is I am excited. I'm extremely excited about the industry, as I always have been. I believe it's going to grow in substantial, maybe unthinkable ways. I believe that it's an enabling technology, as has been mentioned by the CEOs. I believe. And I believe it should impact and touch all of our lives in many different ways. What I don't buy into is how fast things are changing, how fast things will change, how we will have revolution and disruption just days away. That's where I want to dial it back a bit and allow you to decide what the future really holds. Now, part of that comes from the information that's been put out there by maybe some less than informed people. I'm calling it mashups and extrapolations. There is information out there projecting and predicting the future where they don't even realize that they're combining elements of the consumer market and the industrial market, or the industrial and the consumer market, taking a bit of one, adding a dose of the other, connecting the dots where they shouldn't be connected, and saying the future looks grand. What they're also doing, sometimes not even recognizing it, is projecting the future based on a present, but not recognizing that the present is based deeply in the past. The 1980s is indicated hopefully by these hairstyles to the present of the 2010s. So I believe, and I want you to believe, and I want you to use the technology. I'm just trying to dial it back a bit. Now, we have been making progress, exciting progress in the technology, the applications across the board. One example of progress came very recently. I've been in the industry since 1990. For the first 20 years I was in the industry, if someone asked, mate, what do you do? I would consciously choose to say engineering technology, or decide to go into a 5-minute dialogue about this thing called rapid prototyping, the term that preceded 3D printing and additive manufacturing, only to have their eyes glaze over and they still didn't get it. Well, last week I spent the entire week in Scotland with a good friend of mine and an industry expert by the name of Graham Tromans. So we traveled up to Scotland. We were in the tiniest of tiniest pubs having a nice single malt scotch. As the bartender is pouring our dram, he looks up at us and says, mates, what brings you to town? I said, well, we're not coming to Scotland, we're coming to Birmingham for a conference on 3D printing. The gentleman lights up and proceeds to tell us exactly everything he knows about 3D printing. That's some progress. 20 years ago, I'd been more surprised to see that barkeep be able to talk about 3D printing than to see Nessie raise her head right out of the lock. But the interesting thing, dialing back the information to realistic viewpoints, is what he was spouting off to us was partially true. He was shocked, disappointed, and surprised. He was surprised to find that Graham and I have been in the industry for 25 years. He thought it was 4 or 5 years old. He was disappointed to find that you can't just push a button and an hour or so later a finished part is ready for you across the board. And then he was dismayed to find that some of the applications he was touting to us could not be done on a 1,500-pound machine, but maybe require a machine that would cost 300, 400, or 500,000 pounds. So we're progressing nicely, but maybe not at the rate that some are predicting. Part of my realistic nature is having lived through past hype. In 1988, there was a Good Morning America program where an industry executive made the very bold proclamation that soon we will be printing entire car doors, implying manufacturing, not as a prototype. And better yet, we're going to do it in 5 minutes and we'll be able to do it within 5 years. Guess what? Has not happened. In the 1990s, people were predicting that rapid prototyping was going to displace CNC machining, entirely gut the industry, and that this little tiny industry was going to be $1 billion in a few years. Did not happen. So I've lived through the hype and I've become cautiously optimistic about the industry and presenting things in a more realistic viewpoint, which is what I want to leave you with. Another data point is the current state. We're hearing words of disruption and revolution, and it is right around the corner. It's imminent, and it's going to be major, and it's going to change all of our lives in our homes, as consumers, and as business professionals. This was a little straw poll. It is not statistically sound, so don't use this data. Little straw poll, and the question was posed, do you use 3D printing? Extracted just the answers from the engineers. And keep in mind, the question wasn't, do you manufacture with 3D printing? The question wasn't, do you own a 3D printer? The question was, do you use 3D printing? 60% said no. How can we have a revolution in manufacturing or in the home when we can't even capture the majority of the marketplace to do the applications that we excel at? Model making, pattern making, and prototyping. I just think we're going to have a grand future. I think it's going to take a little longer to arrive. The other element of my position is I do not believe that because we can, it will. Because we can does not mean that we will have immediate phenomenal growth and take off. For innovation to happen, for industries to take off, for a product to take off, there's a complex, interwoven tapestry of elements that have to come together. Having great technology that can produce complex parts quickly is just the starting point. You've got the economy and politics, consumer demand, you've got labor cost, and other factors that influence whether it'll take off or not. So we can't predict the future from this one data point, the technology being successful at what it can do. The other factor, which is also very confusing when you're discussing 3D printing, is it is close to true that we can print anything that you can conceive. Now, that's a stretch, but it's close enough. So that we can treat as a given. The problem is people aren't asking. So we can give physical form to any idea. The problem is you got to ask the question, will it perform to my satisfaction? And that can be the properties of the part, that can be the operations, the cost. The other thing is we still have the value proposition to consider. Does the value of the 3D printed part trump the investment of my time, energy, and money? Sometimes in both of those cases, the answer is no. Oftentimes it's yes, and sometimes it's absolutely yes. But that's a gating factor to our growth. Now, as I stand before you, do not treat everything I say as fact, 100% gold, or gospel. I am just one man with opinion. I will not stand before you and present anything I do not believe is the truth, but I'm just one man with an opinion. Studies have shown that experts are no better than 50-50 at getting predictions of the future right. So you can listen to Todd Grimm, or you can go home and roll the dice. Revolution? Yes. Disruption? No. But, so what this means, listen to what I'm saying, listen to what others are saying, compile it and combine it, come up with your own picture of the future. Another interesting point, a recent study showed that in the short term, the 0 to 5, maybe 10-year time frame, experts do have the advantage of predicting the future, but when you go out to 10, you go out to decades, 10 or 20 years, the free thinkers have the advantage. So what we might take from that as a moral of the story is someone coming out from an expert viewpoint might be able to predict the near-term future much better, and then we give it to the free thinkers for the next 10 or 20 years, which maybe means that the big disruption and revolutions take off later than predicted. So I'm going to now move into some evidence of my position, go through what's new, and then I'm going to move into more conversations about this time compression of applications and realization, and finally a barrier, the technical limits to the technology that hold us back a little bit. Now in the what's new section, I'm going to rattle through a lot of new announcements over the last 12 months since the last TCT. My goal is not to teach you about each one of these. It's not even to make you aware of all of them. It's to give you a sense of the grand scope of what's going on. Along the way, I'm going to indicate whether it's incremental growth or progress or innovative and disruptive. The reason I'm doing this is many of the articles we read today treat every single announcement as, yay, we've got a major breakthrough, and therefore tomorrow holds a lot of promise. That's not true. I get a lot of calls from financial people, and they're just like, this industry's changing every single day. It's amazing. I'm like, no. It's interesting, and it's strong, not quite that amazing. So the first off is EnvisionTech announced the 3SP, scan, spin, and selectively photocure. I view this as innovative. It's a brand new technology platform for the company, borrows a little bit from stereolithography, but it gives us another choice on how to 3D print. Likewise, barely, but I'm going to classify Formlabs with their $3,500 US, 3,500 pound, Form 1. I'm going to classify that as borderline innovative, because they've taken the core of stereolithography, driven it down to $3,500 by the use of primarily a Blu-ray laser. So we got two pretty significant changes here. Can't tell you how they're going to impact the industry and growth, but significant changes. Now, on the other hand, Arcam announced the Q10. This is a purpose-built machine specifically for orthopedics. It is a derivative of all their previous equipment. This is incremental progress. Likewise, SLM Solutions, the 500HL. Bigger platform, higher power lasers, incremental development. It's not a game changer. But I'm not putting these down. We need that kind of progress to steadily move forward, to capture that future, along with some innovations. So I'm not downplaying Arcam or SLM Solutions here. I'm just making you aware that we don't have rampant, constant change on a daily basis. EOS came out with the Formiga P100 or P110. It improves the stability, the repeatability, and the throughput of its predecessor, the P100. Incremental growth. They announced 2 new materials. Prime Part Plus reduces the rate of virgin material to recycled material, which is a benefit for users, and also the PA1101, which is a polyamide 11. 2 very important developments, offers material choice. Incremental developments though. Stratasys announced the Object 1000, 1000 millimeters long for the build envelope, a bigger machine. Some people need that. It opens the doors for opportunities, but it's an incremental development. There's nothing under the hood that's significantly different than the predecessors. It announced the Object 30 OrthoDesk. This is a purpose-built machine for dental and orthodontic applications that is merely customized for the workflow. It is the same machine as the Object 30 Pro, incremental development. And finally, the 3Z Max, just announced in the last 30 or 45 days. This improves the throughput of the SolidScape machine. That's a subsidiary of Stratasys for making wax patterns so they can start to tackle the industrial applications. Purely an incremental derivative growth. So here on this page, we have no big breakthroughs and major innovations, but that progress is still good. Now, we do have one on this page that is innovative and a breakthrough. VoxelJet announced the VXC 800. There is no dimension on the spec sheet for the depth of parts you can build because it's built on a conveyance system, so you could theoretically build a part as long as to the back of your walls or keep producing multiple parts 24 hours a day. I view that as innovative. No one else has done that before, and it opens the door to continuous manufacturing using 3D printing, which may open the door to mass production or higher volume production. 3D Systems announced the ProJet X60. This is an incremental growth. These are the platforms we used to know as Z Corporation. They've got new skins, new design, new name, some features under the hood, but primarily incremental growth. They announced the ProJet 3500 Max. Max gives you their highest resolution across the entire build envelope, which their predecessors did not, and adds a tablet interface. If a user needs that and wants that, which many people do, that's a fantastic development, but it's not a major innovative breakthrough. Likewise for the 3510, add the tablet interface, new skins, incremental growth, and finally the ProJet 5000, they doubled the throughput of the machine. Doubled it. That's impressive. That helps us to get to the point of making more parts faster. But still, it's almost identical to its predecessor, so I got to treat that as incremental growth. MCore announced, this is almost a year ago now, announced the Matrix 300 Plus. Triples the throughput of their paper-based process, which we heard about earlier in the CEO keynotes. Incremental growth. Innovative is their Iris. It's only the second machine in the 3D printing space to offer full color. So I treat that as an innovation. Somos, now I'm going on to some materials. Somos announced Somos Next LV Gray. ABS-like properties, but the key here is low viscosity, which means nothing to anyone who doesn't use stereolithography. Low viscosity means it's easier to process, incremental advancement. Microfall announced Centerplast PP. This is for laser sintering, as will all the remainder on the slide be. PP stands for polypropylene. That's a really interesting, powerful development. First time we can have polypropylene on a laser sintering platform. But I still got to treat that as incremental because it's still a thermoplastic. Likewise, Solvay announced Centerline. This is a nylon 6. We haven't had nylon 6 before, but that's still a derivative of all the other nylons we're using. CRP announced WinForm SP. This is a carbon-filled nylon material that retains its mechanical properties at high temperatures. Incremental growth. But it's good. It's progress for the technologies and the platforms. And finally, Bayer announced Desmosint, which is, for sintering again, a thermoplastic urethane for rubber-like parts. Incremental growth. But it moves the industry forward. Moving to the more recent news, we saw the technology partnership. TTP announced the Vista 3D printhead. That printhead can jet ceramics, liquid metals, plastics, biomaterials, electrical inks, and a number of other materials. Quite exciting. That is an innovation. We do not have that in this industry now. That could be a form of a game changer. However, it's only working in 2D mode right now. They haven't even outfitted it to a 3D printer. I can't tell you if it's going to be tomorrow, next year, or 10 years, or if we'll ever see that come out, because there's a lot of things that have to happen for technology to succeed, but it's still exciting. Another exciting, game-changing, possibly in the future, announcement was from MIT, Hyperform. That's a 50-foot chain that you see there, built in a 5 by 5 inch build envelope, build area. They do it by design, by enabling assembly in only one direction, so you pull it out and you start assembling it. That could allow us to make bigger parts in a machine that has a small envelope, expanding our capacity. Challenge here is pretty much a research paper, and they got proof of concept, and they've only worked in one dimension. They haven't tackled 2 dimensions or 3 dimensions, so that would be a future game changer. Likewise with NC State, North Carolina State out of the United States, they are doing room temperature 3D printing of metals. That's exciting, and that could be a breakthrough. But again, research work, proof of concept, no talk of commercialization, and who knows if we'll ever see it. But if we do, it could really break things wide open. Coming up on the final 3 items on what's new, I Am 3D. This will be interesting. First off, that's a rendering, that's not a real machine. Claiming to be able to do jetting of metals in the home. That would be exciting. That is innovative if we see a product. Right now it's stuck in Indiegogo looking for funding. Who knows if it'll even ever take off. But people are thinking in new and different ways, so any one of these could pop and take us in a different direction. It's just not tomorrow. X1 announced iron. We've never had iron before in this industry for 3D printing, but that's incremental. It's adding a new metal material to their platform. And they announced 2 new binders. They expand the range of sand casting tools that they make, or the kind of metals they cast into those tools. And lastly, a company called Kevox very recently announced these 2 machines. It's a derivative using the same basic process of Envision Tech and a Sega, and it's using LED light. So my intent here, again, not to downplay anybody. The progress is needed. It's to give you an idea of the progress we're making. It is quite exciting. That was all in 12 months, and this isn't comprehensive, and obviously I've omitted all the lower cost printers. I just couldn't include them in this conversation due to time. But the key point to walk away with is we don't have daily or monthly phenomenal change that'll just upset industry or upset our industry or propel it forward. The other aspect of my position on enthusiastically realistic is this concept of time compression. Many people fail to realize the rich history that came before an application or a technology. What happens is they don't see the 1980s, 90s, and 2000s. They only see the present and look to the future. And when they do that, they mentally collapse time such that it looks like a lot of development happened in a short period of time. Therefore, if all that happened in a short period of time, look at what tomorrow holds, looking for a skyrocket effect. But that's not necessarily true. I'm going to offer some examples. When I was preparing this presentation, I was sitting with Gary Rubinovitz of Reebok. He's lab manager, their RP operations. He's also past president of the Additive Manufacturing Users Group. I was offering some of my examples. He goes, I got one for you. Nike and New Balance are getting all kind of attention right now. Reebok's a little disappointed with that. Well, what Nike and Reebok are doing are making custom outsoles for elite athletes. Fully customized shoe, perhaps for sprinting. A lot of press, and people are saying, we will soon be making shoes for the consumer. Well, Gary expressed his disappointment, Reebok's disappointment, because they made a custom golf shoe in 1998. Now, if it's going to take off tomorrow, and it's so phenomenal, and it's so easy to do, why has it taken us from 1998 to present day just to get to a few running shoes? Other examples, ripped from the headlines. GE and the LEAP engine, Greg Morris will talk about this, and this is not to badmouth GE. But what we read in the headlines is a fuel nozzle. Successfully tested, moving forward. 19 of these are going to go in each LEAP engine, which means a possible annual production of 25,000 fuel nozzles made with 3D printing, additive manufacturing per year. And they're doing some phenomenal things. They're driving down the weight to get high strength to weight ratios. They're improving the performance. They've gone from what would take 20 components to 1. That's exciting. If I left you there, as many people have done, you may perceive, wow, they're there, now full jet engines, then full aircraft, then spacecraft, and that's going to happen real fast. Let me give you the backstory. According to GE, they've been working with rapid prototyping for the last 20 years. And according to GE, they started this venture 10 years ago. 10 years to get to the point of where they are right now. And that nozzle will go on a LEAP engine in 2 years' time. So we're looking at a 12-year R&D period. Giving you that backstory gives you a little better context of, maybe we're not going to be looking at full aircraft engines tomorrow. It might take a little bit more time. That's why I tell you that story and the time compression effect. It also applies to Boeing. Boeing, according to Graham Tromans, who I spent the week in Scotland with, according to Graham, 100,000 parts have been additively manufactured that are in Boeing aircraft. That's impressive. And they're doing wonderful things with part consolidation, driving down weight, improving performance, really wonderful things. And if you read a story about Boeing doing something great, you could be equally as impressed as the others. But the backstory on that is Boeing started doing this in the late 1990s. They've been working on this for a number of years, as has NASA. Really recent in the headlines. NASA successfully fired an injector for a rocket engine. 20,000 pounds of thrust, 6,000 degrees Fahrenheit, and it succeeded. They commented that this is going to drive down cost and time because to manufacture it traditionally, it's about a 1-year lead time. They think they can get it down to 4 months. So they are pushing forward. So they also, it would have been 115 components. It's down to 1 or 2. They're improving performance, driving down cost, lots of wonderful things. I love the application. Now with this one, I don't know when it started, but what we have to do is look forward. Some people are leaping to the conclusion that we have rocket injectors. No, we have a small scale rocket injector capable of propelling a small missile. And what NASA's statement was is this has given us the information such that we can learn what it will take to make a larger production nozzle. How long will that take? It's certainly not going to be a month or two. It could be years. The other thing about it, actually this goes back to GE. An interesting comment was showing that there's more the interwoven tapestry. Interesting comment was with their success, they now have to build, this is GE, the infrastructure to really get this thing to take off. So it's more than technology. And NASA also, this was referenced by Avi this morning, putting a 3D printer in space. This is exciting, and it leads you to think about colonizing Mars and replacement parts on spacecraft, which is exciting. We will get there. It's going to be an interesting time. The backstory on this one, I sat in on a panel of experts in 2005 down at Marshall Space Flight Center, pondering the question, would 3D printing be beneficial? What technologies would be useful? And how do we go about it? So we're looking at 8 years later to put a test 3D printer in space just to start to work out the kinks, if you will, to discover if we can even really put it on the Space Center or other orbital aircraft. I'm sure it'll happen. I'm just not confident it's going to happen tomorrow. The last element that I want to cover, and I view this as a barrier, because a lot of the predictions just gloss over limitations and barriers. And guess what? Like any technology, 3D printing has quite a few limitations and barriers. We can't do everything and anything to any specification. That's going to hold us back. Unless, and I'll get to the unless in just a second. So we have barriers. If you ask me to meet, well, we have barriers in the areas of materials, the properties, the range of materials that you can select from, size, accuracy, repeatability, surface finish. Barriers with respect to the secondary operations required after a part comes out of the machine, which is rarely ever discussed, and even barriers with ease of use. Yes, we have some systems that are push button. Anyone can learn to operate it in a few minutes, but we also have some systems that after a year of working with them, you're still in an apprenticeship mode to learn how to make that system sing to produce the part that you want. Those are real barriers. If we're operating under current status quo conditions and saying that we want to do exactly what we've always done, but we want it to be better. But they do exist. So that's true of all the systems pictured here. That's true of all the systems out on the floor. That's true of all the systems around the globe. If you look at a standard spec sheet or a laundry list of requirements, we're going to fail on a few, if not many. So the game has to change, I believe. Now, I do believe the technology will continue to advance. We have been chipping away at each and every one of these. I'm pointing down here, you guys are looking up. We've been chipping away at each and every one of these over the last 25 years. That's where we're seeing progress. And we will continue to chip away, but I don't see any of them being eradicated, and certainly not the entire lot. So what that means is, and this proves to be a barrier both for industrial users and also, especially, the home user with the concept of home manufacturing, that means that to do most of the jobs you have in mind, for most of the parts you have in mind, you cannot have one technology. A well-equipped lab will have 2, 3, 4, 5, 6 3D printing technologies, not machines, technologies, so that you have the right system, the right tool, if you will, to choose from when the application approaches itself. So I believe that continues to be a barrier because we're so fragmented on the technologies, and one piece of this device might be good for one technology. I'll go to another project, I have to go to another technology, but they will begin to combine, I believe, and improve. We'll eradicate those. We just won't eradicate them tomorrow. Now here's the challenge. If you continue to operate under a laundry list of requirements that have been established over the last 2 decades at your corporation or 100 years, you're not as likely to succeed with 3D printing. What I challenge you to do is to get rid of some of those requirements. Where we excel, the enabling capability of 3D printing can be released is when we adapt. We being the individual, the department, the company, even industries, when we adapt. And adapt means changing the specifications, asking, do we really need what we have always gotten? Changing designs to leverage 3D printing, leverage what it can do, and also eliminate some of the obstacles. Change mindsets within an organization, change your processes and your procedures. That will allow you to be more successful in doing 3D printing, be it for pattern making, prototyping, and certainly for manufacturing. Without it, if you stick firm with what you've always known, your odds of success are less. Challenge of phenomenal rampant growth with revolutions and disruptions, I believe, is really huge because of this. Because if you look around your corporation, how many people do you know that are really willing to say, I'm ready to adapt and change my designs, my specifications, my mindset, my processes and procedures? There's not a lot of people I know that are like that. That's a barrier. But it's a barrier that will be overcome over time. I'm excited and enthusiastic about the industry. It will move forward in big ways. It's not going to go away. It will change our lives in unexpected ways, and some that we have been expecting and predicting. So we have the number of technologies, our advancements. We've got the incremental progression, but we also have short-term. We've had innovations, and I see more innovations coming. We've got the time compression aspect where it's taken us decades to get to where we are in some applications, but we're going to see some short-term results. And regarding that well-equipped lab of having multiple machines along the technology line, we will see advancements. So we'll keep chipping away at those so we won't need as many pieces of equipment. Now with that, my last thought is the one thing I really enjoy about all the attention this industry has gotten. Some of it is overhyped, some very big claims that just have you going, oh, can't believe someone said that. Best thing is it's drawing attention. And what attention has done is give us the fuel for progress. So I see our innovation curve accelerating. I don't see it turning into a skyrocket. That is a slide up now. I don't see it going up as a skyrocket, but accelerating because instead of a few pounds, we got lots of pounds flowing into the industry. Money is being thrown at 3D printing companies in all ways, from private equity, personal funds, money managers and all that. That is fuel for progress because it gives us the resources we need to advance the technology. And we also have an awful lot of people looking at it, pondering the question, what can I do with 3D printing? What applications? How can I make that technology better? Or what technology can I invent that doesn't even exist today? And that will accelerate our growth curve. So we've got an exciting future. I just believe it's going to be a little bit tempered, a little bit more incremental progress, evolutionary, if you will, rather than revolutionary, but I'm excited. Now, if I've achieved my goal of making you enthusiastically realistic, what I suggest you do when you have a chance to go around the floor is to visit each and every booth with an open mind, absorb information, allow it to wash over you, come into your psyche, don't question it, and start to say, what can I do with that? Be open. Then turn around and get realistic and consider what are the limitations? What are the barriers? What are the obstacles to me doing things? Because you need that information, but don't stop there. What I challenge you to do is take the third and final step, which is to ask the question of what can I do differently to eliminate that limitation that's going to hold me back from doing 3D printing for concept modeling, pattern making, prototyping, or direct manufacturing. With that, I wish each of you best of luck in that rather arduous journey. Thank you.